Hi, in this lesson, we are looking at the building blocks of matter. In our previous lesson, we learned about the particulate nature of matter, where we said that the idea that matter is made up of tiny particles is called the particulate nature of matter. And these very tiny particles of matter are atoms, molecules, and ions. So, every matter in all the states of matter contains atoms, molecules, or ions. And because of that, atoms, molecules, and ions are referred to as the building blocks of matter, meaning that they are the blocks by which matter is built. So in this lesson, we are going to take a look at the building blocks of matter into details. So let's look at what an atom is. Now, the word atom comes from the Greek word atomos, which means indivisible. When we say something is indivisible, it means that it cannot be broken down further. Now, this word atom was brought about by an ancient Greek philosopher called Democritus. So this is indivisible. Now, I would want to explain an atom by using an element. In our previous video, or one of our previous videos, we saw that an element is a chemical substance made up of only one kind of atom. So meaning that every element contains an atom. All right. And the atom is just one kind. Now let's consider this as an element, because gold is an example of element. Carbon is an element. Sodium is an element. Potassium is an element. So let me just pick one of the examples to be gold element. Now what I'm going to do is that I'm going to try to break this gold element into different pieces. Now you agree with me that at a point, that is in the process of breaking this into pieces, at a point, I get a small piece or a piece that I cannot break down further. All right. And because I cannot break this piece further to get other smaller pieces, this small piece becomes the smallest particle of the gold element. All right. The smallest particle of the gold element, because I cannot break down this into other smaller pieces. And because of that, it becomes the smallest particle. Now, the smallest particle of every element, which cannot be broken down further, is what we call the atom. Now, this smallest piece called atom, because it is coming from, or it is taken from, the entire gold element, it will exhibit properties similar to the entire gold element. So any chemical property that the gold element can undergo, the smallest particle, which is the gold atom, can also undergo the same chemical property. And as a matter of fact, the ability of every element, example being the gold element, to undergo chemical reaction is solely determined by the atom being the smallest particle. In other words, the chemical property or the ability of every substance to interact with other elements to produce different substance is determined by the atom. So without the atom, an element cannot undergo chemical reaction or chemical change. So what then is an atom? An atom is defined as the smallest particle of an element, which undergoes chemical reaction. Now, an atom, like I said, retains the property of an element. Because the atom is taken from the element, every property of the element will be exhibited by the atom. And so the atom will retain the original properties of the element. So that is what an atom is. Now, let's look at some examples of atoms. Now, all examples of elements are also examples of atoms. So we can talk of gold, we can talk of potassium, we can talk of sodium, we can talk of chlorine, we can talk of iodine, we can talk of argon. All these are examples of atoms, and they are also examples of elements. Okay, now still on atom, let's look at the parts of an atom. Now, every atom is made up of the center. Every atom contains a center. In a microscopic view, the atom contains a center. And in this center, we have protons and neutrons. Then, around this center, we have what we call the shell. And on this shell, we have what we call electrons. And these electrons move around the center of the atom. The center of the atom is actually called the nucleus. So every atom has a center called nucleus. And in the nucleus, we have protons and neutrons. Then around the nucleus, we have what we call the shell. The shell provides the path on which electrons move about. Now, the atom will be explained in details in subsequent videos. Now, let's look at molecule, what a molecule is. Now, to explain what a molecule is, let's consider these two atoms, atom A and atom B. If I am able to bring these two atoms together, all right, as a result of a chemical attraction or an attraction between them to form this, then this is called a molecule. All right, so we have two atoms. By means of force of attraction, we've been able to bring these two atoms to form this. Now, this new substance we formed is what we call a molecule. So for every molecule, there exists what we call force of attraction between atoms. Now, these two atoms can be either different, like what we have here, or they can be the same. All right, they can be the same. So I can combine A and another A, and by means of a force of attraction, I get this. Now, this force of attraction is called chemical bond. So this force of attraction between the atoms is called chemical bond. So a molecule can be defined as a group of atoms chemically combined by a chemical bond. That is what a molecule is. A group of atoms chemically combined by a chemical bond. Now, a molecule can also be defined as a group of different or same atoms chemically combined by a chemical bond. All right. So I can just add same or different. All right. So a group of same or different atoms chemically combined by a chemical bond is what we call a molecule. Now, there are two broad categories of molecule, which are homonuclear molecule and then heteronuclear molecule. Homonuclear molecule is actually a molecule produced by combining same atoms. All right. So homonuclear molecule is a molecule produced by combining same atoms. And heteronuclear molecule is a molecule produced by combining different atoms. Now, let's look at examples of molecules. So, examples of molecule are carbon dioxide, which is CO2, water, nitrogen gas, hydrogen gas, hydrochloric acid, sulfuric acid, all right, sodium chloride. All these are examples of molecules. Now, we can group these examples of molecules into homonuclear and heteronuclear. So, homonuclear is between same atoms. So, example can be nitrogen gas, hydrogen gas. We can also talk of chlorine gas, fluorine gas. So, all these are examples of homonuclear molecules. Now, let's look at heteronuclear molecules. So, that is molecule produced between different atoms. So, we can talk of water. We can talk of hydrochloric acid. We can talk of sulfuric acid. We can talk of sodium chloride. So these are heteronuclear molecules. Now, in every molecule, the number of atoms that come together to form the molecule is called atomicity. It's called atomicity. So atomicity is defined as the number of atoms that come together to form a molecule. So let's take a look at a molecule like sulfuric acid. Now, in sulfuric acid molecule, or in H2SO4 molecule, we have 2 hydrogen atoms plus 1 sulfur atom plus 4 oxygen atoms, and so the atomicity of H2SO4 is 7. What about water? Water is made up of 2 hydrogen atoms plus 1 oxygen atom, and so it has atomicity of 3. Sodium chloride has atomicity of 2 because it's made up of sodium and chlorine. What about HCl? The atomicity is 2. Now, based on atomicity, we can also classify a molecule as monoatomic molecule, diatomic molecule, triatomic molecule, and then we can talk of polyatomic molecule. Now, what is monoatomic molecule? Monoatomic molecule is simply a molecule whose atomicity is 1. Whose atomicity is 1. And an example of monoatomic molecules are group 8 elements, which are argon, neon, helium, and xenon. All these are molecules, but their atomicity is just 1. So we see that group 8 elements are monoatomic molecules. Now, diatomic molecules are molecules whose atomicity is 2, meaning that it's made up of 2 atoms. All right, made up of 2 atoms. So an example is hydrogen gas, nitrogen gas, fluorine gas, chlorine gas. They are diatomic. Right? They are diatomic. What about triatomic? Triatomic is a molecule which is made up of 3 atoms, or which has atomicity of 3. And an example is ozone. Ozone is O3. So the atomicity is 3. So ozone is triatomic. It's triatomic. Now, what about polyatomic? Polyatomic molecule is a molecule whose atomicity is greater than 3. All right. So you can talk of atomicity of 4, atomicity of 5, atomicity of 6, 7. All are polyatomic molecule. All are polyatomic molecules. So you can talk of H2SO4 with atomicity of 7. All right, you can talk of H3PO4. All these are polyatomic molecules. Now, a molecule will be studied into details in subsequent videos. Now, let's look at what an ion is. Let's look at what an ion is. Let's look at what an ion is. Now, let's take this to be an atom where we have electrons on the shells. We have electrons on the shells. Now, these electrons on the shells can be lost. Some of them can be lost, or new electrons can be added. All right. So you can lose some of the electrons on the shell, or you can add new electrons on the shell. If you lose some of the electrons on the shells of an atom, we see that the atom becomes positively charged. Then if you add new electron to the shells of the atom, we see the atom becomes negatively charged. Now, any atom which can exist in either this or that is called an ion. So an ion is defined as an electrically charged atom, or simply put, a charged atom. So a charged atom, let me be more specific. An electrically charged atom is ion. All right. And we've seen from here that the charge can be positive or can be negative. And so because of that, we have two types of ions. We have positively charged ions and we have negatively charged ions. Now, positively charged ions or atoms, they are called cations. And those that are negatively charged are called anions. So there are two types of ions. We have cations and we have anions. Cations are positively charged atoms. All right? Positively charged atoms are cations, and negatively charged atoms are anions. Okay, so now let's look at examples of cations. Now, examples of cations, we are just looking at examples of atoms that can lose. So sodium can lose one electron. So sodium positive, potassium positive, lithium positive, and we can also talk of calcium 2 positive, magnesium 2 positive. We can talk of aluminium positive. Now, sodium can only lose one electron. That is why it is positive. The same thing applies to potassium, lithium. Potassium, lithium, and sodium, they can only lose one electron. And so they have positive 1. Calcium, magnesium, they can lose only 2 electrons. And so we have what? 2 positive. Remember I said when you lose, you become positive. So they lose 2 electrons. That's why they are 2 positive. Aluminium can lose up to 3 electrons. And so it is 3 positive. Now let's look at examples of anions. So we can talk of chlorine minus, fluorine minus. We can also talk of iodine minus. We can talk of oxygen 2 minus. We can talk of nitrogen 3 minus. So all the, and we can also talk of sulfur 2 minus. So all these are examples of anions. My word. Chlorine, fluorine, and iodine, they have -1 because they can gain 1 electron. Only 1 electron. Oxygen and sulfur, they have 2 minus as their charge because they can gain 2 electrons. Nitrogen is 3 minus because it can gain up to 3 electrons. And so it is 3 minus. Thank you for watching this video. I will end here. And please, if you have any question, kindly leave it in the comment section. And please don't forget to like this video and let me know what you think about the video. And kindly subscribe to this channel and recommend this video to others.